Okay, so let's talk about logarithms. So hopefully you guys remember we talked about how we could write it like log base first number, and then we called what that x is there, our middle number equals the last number, and how we could rewrite these so we can write them in exponential form. Remember, we go first, last, middle, so it'd be the first number to the last power equals the middle. So when we rewrite this one, we would have 2 to the negative 3 power equals x. And then we know that negative exponents just mean we push it into the denominator, so we've got x equals 1 over 2/3, and or 2 to the third, and 2 to the third is 8, so x equals 1/8. Alright, so now if this one, the first thing you'd want to do is draw a picture. So we'll label our vertices here, A, B, and C. Now we're trying to find, we're given that AC is 17, angle ACB is 48, and that CB is 10. So we'll go ahead and label all that stuff. And notice how we have an angle inside two sides that we know the length of. That's a giveaway that we want to use law of cosines. So the law of cosines, we'll go through that afterwards, but I forgot my x squared. That should be x squared equals 17 squared plus 10 squared minus 2 times 10 times 17 times the cosine of 48 degrees. So we just type this into our calculator and we get x squared equals approximately 161.496. So we got to take the square root, and we end up with, rounding to the 10th, that x equals 12.7. Okay, so let's review the law of cosines. You should have did this in geometry. So we'll call the opposite sides of each angle lowercase a, b, and c. And so let's say we're given angle A, and hopefully we would also know side C and side B. So we can say that side A is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So notice, we square both of the sides and add them up, and then we subtract 2 times the other two side lengths times the cosine of the angle opposite the side we do not know. All right, so with this one, just memorize this, that its cosine is x and sine is y. We'll discuss this more in class. All right, so hopefully remember the range is what the y values vary from. So we can see this one goes up to a half and then down to a negative 1/2. So A and B can't be it because those are x's. That's referring to a domain value, so those can't be the right answer. And then notice D is from negative 1/2 up to 1/2. All right, so we'll talk more about the graphs of sine, cosine, and tangent in class, but the first thing is the sine. I'm just going to draw 0 to 2 pi first. Our important points are pi over 2, pi, 3 pi over 2, and then 2 pi. Sine starts at 0 and then goes up to 1 and down to negative 1. So you start at 0, at pi over 2 or at 1, pi over at 0, at 3 pi over 2 or at negative 1, at 2 pi we're back to 0. And then it just keeps repeating itself over and over and over again. So let me resize this and we will go back to negative 2 pi now. So remember, it just keeps repeating itself, so we're just going to continue this graph backwards. So negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. So if we keep drawing this pattern, we'd be at negative 1 at negative pi over 2, back to 0 at negative pi, then at positive 1 at negative 3 pi over 2, and then back to 0 at negative 2 pi. So our two minimum values occur at negative pi over 2 and at 3 pi over 2. Okay, so again, we'll discuss this more in class, but the amplitude is defined by how high and how low the graph actually goes. What is the maximum of the range and what is the minimum of the range kind of help define the amplitude. So the amplitude is actually really easy to spot with the equation. So the amplitude is defined by the number in front of the sine or cosine function, and we take the absolute value of that. So amplitude can never be negative. So A is obviously an incorrect answer. Okay, and the period is, one cycle of the graph because, like I said, in the previous problem, it's repetitive. So as soon as it starts repeating itself, we've reached the end of the period. And the B value helps us find the period of the sine or cosine graph. So the period equals 2 pi over B. So if we look at this problem here, we can see the A value is 2. So the absolute value of 2 is just 2. And then the B value is 1. So 2 pi over 1 is just 2 pi. So we have an amplitude of 2 and a period of 2 pi. So our answer would have to be B. Okay, so with this problem here, we just kind of have to think logically about this. It takes 3 hours to complete a job with one printer. Another printer can do it in 4 hours. So that job over 3 and then that job over 4 equals the amount of time to complete that one job for both printers. So I'm going to multiply everything by 12 just to clear out the fractions. I get 4x plus 3x equals 12. So 7x equals 12, divide both sides by 7, and we get x equals 12 sevenths. So with both these printers running, that's how long it would take. Okay, so we just have to simplify this. So I'm going to break everything apart into whatever roots I need. So the cube roots, I'll break apart perfect cubes. The fourth roots, I'll look for things to the fourth power. I'm just going to go through and cancel everything out. Okay, so notice here we still have a radical 2 on the bottom. So we got to multiply the top and bottom by square root of 2 so we don't have any radicals in our denominator. I accidentally wrote a 3, but that should be square root of 2. And now we see that we can reduce things down. So we can divide the 6 and 4 by 2, make it 3 halves, just have x cubed on bottom and y squared on bottom, no x and y's on top now. And then we just copy down all of our roots. Okay, so with these, remember we have to multiply by the conjugate. So the conjugate of the denominator here is 4 minus radical 2. So we multiply the top and bottom by 4 minus radical 2. Again, I think the easiest way is just use the box method to multiply out the numerator. So we'll do the box. And just multiply everything out. So 16, 4 radical 6, negative 4 radical 2, and negative radical 12. But square root of 12 is 4 times 3. So the square root of 4 is 2. So we got negative 2 radical 3 there. Want to make sure you have them simplified. And the denominator, hopefully remember that conjugates cancel. All we have to do is the first times first minus last times last. And we end up 14. So now when we set this back up, I think we're going to see that we can reduce this down. So we got 16 plus 4 radical 6 minus 4 radical 2 minus 2 radical 3 all over 14. So everything has an even coefficient, so we can divide everything by 2. So we end up with 8 plus 2 radical 6 minus 2 radical 2 minus radical 3 all over 7. So our answer would be B. Okay, so with this one, we need to pull out all the perfect squares. So square root of 16 is 4. We got 2 w's underneath the radical, so we can pull out 1. Then we can pull out a y, and we still have 1 y left over. Now in 75, it's 25 times 3, so square root of 25 is 5. Got a 3 left over. Then we can pull out 2 x's, and we still have 1 left over. Now we have to rationalize the denominator. We can't have a radical there, so we multiply the numerator and denominator by square root of 3x. Then after we do that, we do need to check to make sure we can't reduce anything, and we can't, so that is our final answer. Okay, so with this problem, we need to just read it, pull out all the important information, and plug it into the formula they give us, and solve for h. Okay, so the best thing we can do for this problem is actually draw the angle. We know it's in the third quadrant, so we'll make a triangle. And the tangent of that angle is opposite over adjacent, so we'd have negative 4 and negative 3 as our two measurements. Now we can find the hypotenuse by using the Pythagorean theorem. and we get that c equals 5. So now we can find the sine of this because the sine is opposite over hypotenuse, so it'd be negative 4 over 5. So with this problem, we need to know what cosine actually looks like. Cosine starts at 1, and then at pi over 2 goes down to 0, and then at pi it's at negative 1, 3 pi over 2 is 0, and at 2 pi we're back to 1. Alright, so if we're going 3 1/4 revolutions clockwise, that's moving in a negative direction. So that's 360, here's another 360, there's another 360, and then a quarter would be 90 more degrees. So we know we went around 3 times. 360 degrees is equal to 2 pi radian. So we can do negative 3 times 2 pi to get the 3 revolutions clockwise. And then we have to add the 90 degrees, which is pi over 2. But since we're moving in a negative direction, we're adding negative pi over 2. And we end up with negative 13 pi over 2. Okay, so with this problem, we just need to set up the proportion. We know that the cost of each one would be 500 plus 3 times x, all divided by x, so we can get the average price, and we want it to be less than 375. So now we just go through and solve for x. Okay, so with these problems, you just want to go ahead and plug in everything and get it into the terms of c. So we can replace the a with b squared, and then we can replace the b with c squared, and then we can go back and replace the b's again with the c squareds. You just got to pull out anything that you can get outside the radical. So really just need to remember what an exponential function looks like. Remember, it's a times b to the x, where a is the y-intercept and b is your growth factor. Remember, this also looks a lot like geometric sequences. Okay, so with this problem, we're going to go ahead and set it up and see what we need to use. Probably going to have to use law of sines or law of cosines, since we do not have a right angle. Okay, since we're trying to find the height, I want to find the length of another leg of this triangle. So I'm going to use law of sines. So I can set the law of sines up by finding that third angle. Just do 180 minus 46 minus 52, and then I have a proportion there. Okay, so I'm going to find that side x. I'm going to just set up my proportions, and I will solve for x.